Recording in
Meyerton, today I'll be doing what we call nature of roots. What are nature of roots really all about? Basically, what nature of roots inform you even before you solve the equation. It explains to you what type of solution are you going to have. Are you going to have an irrational solution, a rational solution, unequal solution, or one solution which is equal solution? Basically, you can actually determine the type of solutions you will have, especially when you solve for x or you solve for y, before you even solve the actual equation. That's what nature of roots enables you to do. And I will start with the basics. Before solving an equation, you must do a quick analysis to determine what type of solution to expect. We call that the nature of roots. A root is simply a variable you are solving for in an equation. We use a discriminant to get the true analysis. The discriminant is determined from the quadratic equation where you have ax squared plus bx plus c is equals to 0. Now the discriminant formula will be delta is equals to b squared minus 4ac. What can we say about the discriminant? The discriminant formula is part of the quadratic formula as derived under equation. And when you look at the quadratic formula, under that square root, that's what the discriminant is. That part over there is what we call the discriminant. Now, if your discriminant is less than 0, that is when your discriminant is negative, it means that you will not be able to find the square root. And if you can't find the square root, it means that we will not have a solution, or we'll have a complex solution. I don't want to say we don't have a solution. We do have a solution, but it is a complex solution. Now, what if the root, that b squared minus 4ac underneath the root is 0? What type of solution are we going to have? Then it means there will be one real solution, which means that your solution will be real and equal. Now, what if the discriminant is greater than 0? Then it means that we'll have two unequal solutions. That's what it tells you. All right. Now, I just need to specify something here, that you'll have two unequal solutions, obviously, if your delta is greater than 0, or your discriminant is greater than 0, you'll have two solutions. But now we need to ask ourselves, what type of solutions will they be? All right. Now, if it's greater than 0, as I've said, we will have two solutions. But what if it's greater than 0 and it is not a perfect square? If it is not a perfect square, those two solutions will be real and irrational. And obviously, they will be unequal, right? However, if delta is a perfect square, or the discriminant is a perfect square, what does that mean? It means that we're going to have two solutions still, but these solutions are going to be real and rational. Okay? If it's not a perfect square, they will be real and irrational. If it's a perfect square, they will be real and rational. Guys, this is all what nature of root is. It has those four conditions I have specified. Okay. Now, let's do the analysis quickly. The sign and value of the discriminant informs you about the kind of solution you are going to have, right? If the discriminant is greater than 0 and it is not a perfect square, then your solution will be real and irrational, and it will be unequal. The fact that delta is greater than 0, it informs you that you'll have two unequal solutions. Okay, if it's equal to 0, then you have one equal solution, which is one solution in a way. All right. If the discriminant is greater than 0, it means that, and it is a perfect square, it means that you'll have a rational solution, but there will be two solutions and they'll be real. If the discriminant is equals to 0, as I've specified, it means that there will be only one real solution, which is a rational number. Good? All right. Rational numbers are numbers that can be expressed as a fraction. Remember that a fraction has a numerator and a denominator. Non-recurring decimals are considered to be irrational numbers, and we normally say they'll be unequal and irrational. All right. And now let us look at this here. So this is just a summary, two solutions. If delta is greater than 0 and it's not a perfect square, then you will have unequal and irrational solution. Okay, that is if delta is greater than 0 and it's not a perfect square. Just remember that. And if a delta is greater than 0 and it is a perfect square, you will still have unequal solutions, but they will be irrational. If delta is equals to 0, then you'll just have one real solution as I've specified. If delta is less than 0, then you will have a non-real solution, which is an imaginary complex number. All right, for those that are doing AP maths, you'll know what I'm talking about. Right, let's move on. Now, we need to determine the nature of roots of each equation. Solve the equation if they are irrational coefficients in the equation. So basically, we need to solve for the equation if and only if there are irrational coefficients in the equation. First of all, I'm simply going to determine the nature of roots here. And when I determine the nature of roots, I will simply use the discriminant, which is b squared minus 4ac. Where there's b, I will substitute -5, and where there is a, I will substitute 2. Where there is c, I will substitute 3. Solving this will give me the value of my discriminant. And as I've said, b will be -5, a will be 2, and c will be 3. When you simplify this, it'll give you 25 minus 24, which is 1. So here, delta is equal to 1, which is a perfect square, by the way. That 1 is a perfect square. And can we agree that 1 is also greater than 0? So we'll have two unequal solutions. And the fact that it's a perfect square, it'll be two unequal solutions that are rational. If it's a perfect square, solutions will be rational. See? Easy. Okay, let us see if this is true. Let's solve for that equation. Obviously, we know that the last term there is positive, so brackets will both take the negative sign, and you just find your factors. When you multiply the inner and the outer, they must give you that -5. Okay, and obviously, when I multiply the inner and the outer, I'll get in the inner, I'll get -3 x, and the outer will get -2x. When you add them, they will give you the middle term. Why am I adding them? Is because the last term is positive. So if the last term is positive, you just add the inner and the outer to get the middle term. Now, when you solve for x here, x will be equals to 3/2, and the other x value will be 1. So these are two unequal solutions. Are they rational? Yes, 3/2 can be expressed as a fraction. 1 can also be expressed as a fraction, which is 1/1. So do you see what the nature of roots has done? Awesome. Don't you think? Now, what type of solutions are we going to have here? Someone can say, yeah, but we can't factorize that. So it's obvious. But let's see if this discriminant thing works out. So we will use the discriminant formula, which is b squared minus 4ac. Where there's b, we'll substitute 4, and where there's a, we'll substitute 4. Where there's c, we'll substitute 1. You'll end up having 16 minus 16. And when you take those two, it'll give you 0. Okay, so delta is equals to 0. It is not negative, it is equal to 0. So the fact that delta is equals to 0, it means that we can solve that equation, that we can actually factorize that. And by the look of things, obviously whatever we get will be one real solution. By the look of things, that will be a perfect square. Let's see if that is true. So we know that delta is equals to 0 under the root, and the fact that it's under the root and it's equals to 0, it means that we'll have a real solution that is rational and it's equal. So it will have only one solution. Okay, let us see if this is true. You just have to factorize that. As I've said, it will be a perfect square, and when you factorize that, it'll just give you one x solution, which is x is equals to -1/2. And is the solution corresponding to the nature of root? Yes, it does. Easy, hey? I did these notes like a while back, hey? A while back. When I had a lot of passion for maths. It's slowly coming back. My grade 8s are just, yeah, getting me there to the edge. Because I used to love teaching maths. Maths was such an awesome subject. Anyway, it is still an awesome subject. Let us look at this here. Let's calculate the discriminant. So where there's b, we'll substitute negative. Well, actually here, where there's b, we'll substitute -1. Where there is a, we'll substitute 2. Where there's c, we'll substitute 0. And when you do that, what do you get as a discriminant? Now let's substitute everything there and see what we are going to get. All right. Let's just go through it quickly. This is what we'll have. Where there's b, we substituted -1. Where there's a, we substituted 2. And where there's c, we substituted 0. Now you will realize that the second part will give you 0. So you'll end up having -1 squared. That will give you 1. So our discriminant is equals to 1, which is a perfect square. So we'll have two unequal solutions, two real unequal solutions that are rational. Let us see if this is true. Just factorize that and solve for x. So when we factorize that, we'll take out a common factor. We'll end up having x is equals to 0 or x is equals to 1/2. So this is true. Got it? So you determine the nature of it. It will simply tell you what type of solution you are going to have. What about this one here? I will calculate delta before I even get to factorizing that. When I calculate delta, this is what I will have here. I will end up having -13, I think. No, -15. -15. And -15 means that delta is negative. And the fact that delta is negative, that tells you that we will not have real solutions. There is a negative number under the root, so we'll have non-real solutions or complex solutions. All right. Let us see if this is true. Obviously, we can't factorize that. And this equation may not be factorized when computed into a calculator. It gives an error. And when you compute it into a calculator, basically, this is what we're going to do when you put it into a calculator. We are going to use the quadratic formula, right? Now, all right, I'm just going to erase everything there. Let's see. All right, so what are we going to have there? It's normally okay, I can't show it to you here. It's my other calculator that can. Just wanted to show you how I got to it. All right. I don't think I can do it with this calculator here. I'll just have to say it out as I go through it. Don't have a choice. Okay. I wanted to show you the quadratic formula, but it's fine. So here we have negative, and where there's b, we'll substitute 1, and we will square that. Okay. Then we're going to have, obviously, you can't compute plus and minus at the same time. Then you're going to have the square root of, again, where there's b, we'll substitute 1 and square it. Interesting. And then you minus 4, where there's a, you will substitute 9. And where there is c, you will substitute 1. And then put this divided by 2. Again, where there's a, you will substitute 9. Then press the equal sign. Voila, error. See, nature of risk never lie. you could tell from determining the discriminant what type of solution you are going to have. So there's no need to actually solve the solution once you have determined the nature of roots. The root here simply represents a solution. Okay. Now, these are the questions that they love asking in past papers. For which values of R will that have real roots? Know that for you to have real roots, it doesn't matter. They didn't say rational. Okay, if they said rational, we know that our discriminant will have to be equal to a perfect number. All right. They just said real roots. Now, the fact that they said real roots, all I'm going to do is to calculate my discriminant. You will notice that here B is -5, A is 1, and C will be R. Just substitute them into the formula, and this is what you will have. As I've specified, B is -5, A will be 1, and C will be R. Right? And when you determine the discriminant, it'll give you 25 minus 4R. But because they said you need real solutions, we know that this discriminant must be greater or equal to 0. If they said rational, we wouldn't have the greater part. If they said rational, we wouldn't have the greater part. We'll just have equal to 0, because now if we say it's greater, then it'll be hard for us to determine what a perfect square is. All right. If they said equal, actually, we'll say the discriminant is equals to 0, which is one real solution. But here, when they say rational and irrational, now that is a little bit complex, right? So we know that for us to have a real solution, our discriminant must either be greater than 0 or it must be equal to 0. Well, I'll do a lot of questions that take into account rational and irrational as well. So here we know that for us to have real solutions, our discriminant must be greater than 0 or be equal to 0. So we're going to take that discriminant and make it into an inequality. When you solve an inequality, this is a linear inequality, so we'll just have to transpose 25 to the other side. It will be -25. Please note that when you transpose, the inequality sign does not change. It only changes when you divide by negative or when you multiply by negative. I don't have a choice here. To solve for R, I'll have to divide both sides by -4, and the inequality sign will change directions. Now it was greater or equal to, it'll change to R being less or equal to 25/4. So R will have to be less or equal to 25/4 for us to have a solution that is real. We good? Awesome. Math is fun. I know, it's such a beautiful subject. I actually miss teaching math. It is a nice, beautiful, relaxing subject. It opens one's mind. It's actually, when you learn math, it's like you're in therapy. It massages your brain and helps you relax. Such a beautiful subject. Alrighty, if you like me to keep on making math videos, please don't forget to like, subscribe, and share on your social medias. And tell your friends about my channel. Thank you for supporting. Khotso.